This is most of the hardware for the Pollinator kit, all assembled in a prototype, with the exception of the two MP3 modules that will provide the sound. They have yet to be integrated, but everything else is there. So we're going to have 12 to 18 volts coming in. This is a little buck converter that generates 5 volts that powers the ESP32. Two stepper motors, drivers, stepper motor. They take their power directly from the 12 to 18 volts. ESP32 talking to this multiplexer because we ran out of pins. Now this is then going to, this will be the inputs for the joysticks and the coin mech and all that kind of stuff. They've got an input there for the addressable LEDs, which sit behind the scores holes. We've got another output for the scoreboard, which we'll talk to you about in a minute. And then we have these inputs. They were attached to the interrupts, but the code was just not working. No matter what I tried, it was generating all kinds of erratic behaviour. The stepper motor was running backwards at one point. The voltage thresholds are all messed up. But I've just gone to using a conventional digital read for the holes, and it works fine. Obviously you have to have an awful lot of instances of it throughout the code, but I'll just do that. I'll just have it just check those these light gates continually to make sure that it's working up. So if I power it up, so the stepper motor was running. That's just to show you that it's going. This is the model of the machine itself. Now the scoreboard has got a bit of a glitch in it. This little thing is, I can't remember what the number is, max 27 something something or 72 something something. It is fouling up on startup, but if I hit reset, it works fine. So there's something about the startup, maybe the power's not coming in right, or some initialization problem, but I'm sure I'll figure that out eventually. So now that works, we can see how this goes. So ball return, so the score hole goes yellow, and then goes through a light gate, turns red, so it's detected that hole. Ball returns to bottom, returns again, goes yellow again, and mechanically this is all nice. This is all working really well now. This hole is so much more sophisticated than it looks. It's got a straight edge, and then it's got a chamfered edge just at the bottom using an 11-degree router bit. I was going to make it a conical hole with the router, but it used up so much space at the back because it's become quite thick. It needed the depth for the ball to have enough room so it didn't detect the ball when it was just at the edge of the hole. So if I used the conical hole, it used up so much room in the back that I couldn't fit the sensors in without it colliding into the next hole when it gets quite dense at the top. So it's now got a straight hole, but with this little chamfered edge. I think it looks fine like that. I don't think you can tell, but it definitely makes a difference. This is sitting at exactly at 90 degrees, and there's never an instance of the ball just hitting the edge. It always is positively out or positively in, which is what you need. So it's all shaping up quite nicely. Basically that is the hardware done, with the exception of the sound. It's just a case of taking this and scaling it up to a full size one. The ball return mechanism works well, the little bit piano wire works well. Yeah, it's all good. So onward.